Yesterday, Maya was a high school student bored in physics class doodling constellations in her notebook. Today the sky is gone, not metaphorically, gone. A shimmering silver curtain replaced it, blotting out the sun, the moon, the stars. Panic floods the streets. Sirens wail. The world ends, not with a bang, but with a silent silver shimmer. The air crackles with an unfamiliar energy, a metallic tang clinging to the back of her throat. Every electronic device sputters and dies. Cars grind to a halt, their engines coughing their last. Dogs howl, sensing something profoundly wrong. Maya clutches her notebook, the familiar weight grounding her as she stumbles through the deserted streets. The silver curtain pulses rhythmically, casting an eerie, ethereal glow on the abandoned cars and terrified faces. People scream, point, and pray, but the silver remains, an impassable barrier between Earth and what was. Imagine that Maya, struggling to comprehend this impossible reality, suddenly remembers a drowsy lecture about the solar system, planets, and their secrets. It was a lecture designed to lull students to sleep. But could it hold a clue? Our solar system, our home in the cosmos, a unique, dynamic, and wondrous system forged billions of years ago, still shrouded in mystery. It's a grand gravitational dance, with our star, the Sun, at its heart. 8 planets orbit this fiery centre, accompanied by over 200 known moons, countless asteroids, comets, and specks of interplanetary dust. Gravity binds them all, creating a complex and harmonious structure. The sheer scale of our solar system defies comprehension. Including the distant Oort cloud, its diameter stretches nearly 2 light years, a staggering 19 trillion kilometres. Picture the Sun as a soccer ball. Earth would be a tiny pinhead, orbiting 30 metres away. 4.5 billion years ago, a colossal cloud of gas and dust began to collapse under its own gravity. At its core, a dense nucleus formed, the proto-Sun. Soon, thermonuclear reactions ignited, and a star was born. The remaining matter coalesced into a swirling disk, giving birth to planets, moons, and other celestial bodies. This process is the key to understanding the formation of star systems throughout the galaxy. Our solar system is a unique laboratory for studying phenomena occurring in other star systems. Our cosmic neighbourhood resides within the Milky Way galaxy, home to an estimated 400 billion stars. We occupy the Orion Arm, a spiral arm situated approximately 27,000 light-years from the galactic centre. This is a relatively calm region, a factor that likely played a crucial role in fostering conditions conducive to life. Spiral arms are prominent features in spiral galaxies, luminous, winding regions brimming with star formation, gas, and dust. Our arm lies between the larger Perseus and Centaurus arms, a location that offers relative safety, distancing us from the galactic core's intense activity. The solar system races around the galactic centre at approximately 828,000 kilometers per hour. However, a complete orbit takes between 225 and 250 million years, a galactic year. The last time we occupied this precise location in the galaxy, dinosaurs roamed the Earth. Incredible, isn't it? If you could observe the Milky Way from afar, the solar system would appear as a barely perceptible speck among trillions of stars. Yet, upon this tiny speck, life blossomed, a phenomenon we have yet to discover anywhere else in the universe. What if the silver curtain lies in understanding our place in the vast universe? Consider how our understanding of cosmos has evolved. In antiquity, people believed that Earth was the centre of the universe. This geocentric model, proposed by Ptolemy, reigned supreme for nearly 1500 years. According to this model, all celestial bodies, including the sun, moon, and stars, revolved around Earth. The 16th century witnessed a pivotal shift in the history of astronomy. Nicholas Copernicus, a Polish astronomer, hypothesized that Earth was not universe, but simply one planet orbiting the Sun. This discovery formed the basis for the heliocentric model. Unsurprisingly, this idea faced resistance, as it challenged centuries-old beliefs about humanities. Copernicus, however, laid the foundation for a revolution in astronomy. Galileo Galilei marked the next crucial stage. In the early 17th century, using an improved telescope, Galileo became the first to observe the moon's surface, revealing craters and mountains that contradicted the notion of its perfect sphere. He also observed the phases of Venus, providing compelling evidence. These discoveries confirmed Copernicus's hypothesis and forced a reassessment of the foundations of astronomy. Isaac Newton completed this process in the late 17th century. Through his laws of gravitation, he explained why planets orbit the Sun. Newton demonstrated that gravity is the force that binds all celestial bodies, from moons to distant planets, to their orbits. His work formed the cornerstone of classical mechanics and enabled more accurate predictions of planetary motion. The late 19th and especially the 20th centuries ushered in an era of practical space exploration. In 1969, the Apollo program successfully landed humans on the Moon. With the development of spacecraft and telescopes, humanity began actively exploring not only the nearest planets, but also the far reaches of the universe. The Hubble Space Telescope, launched in 1990, opened new horizons, providing astronomers with incredibly precise data about stars, galaxies, and other cosmic objects. Thus, the journey from the geocentric model to modern scientific understanding of the cosmos has traversed crucial discoveries and revolutionary ideas that transformed our understanding of the universe. Maybe the secrets hidden in this historical shift can also reveal something about what Maya witnesses now. Let's turn our attention to the planets closest to the Sun, known as the inner planets: Mercury, Venus, Earth, and Mars. They form a unique group of rocky bodies, distinctly different from the gas giants in the outer solar system. Let's begin with the smallest but fascinating planet, Mercury. Mercury is the closest planet to the Sun, and everything on it is influenced by this proximity. It orbits at an average distance of about 0.329 astronomical units, AU, slightly less than half the distance between Earth and the Sun. 1 astronomical unit is approximately 150 million kilometers. This places Mercury on average only 58 million kilometers from the Sun, making it the innermost planet in our solar system. Mercury is a planetary dwarf. Its diameter is approximately 4,180 kilometers, about 2.5 times smaller than Earth's diameter. Despite its diminutive size, it is denser than many other planets due to its large iron core. But that was only the beginning. Yesterday, Maya her notebook. Today, the sky is gone. Not metaphorically. Gone. A stars. Panic floods the streets. Sirens wail. Sensonoia pogrążenia. Mercury, often overlooked, is more than just a sun-scorched rock. Imagine a world where the Sun appears 3 times larger than it does on Earth. A world where a single day lasts 176 Earth days. A place of extremes. The Sun beats down with relentless fury, baking the surface to a scorching 430 degrees Celsius. Then, as darkness descends, temperatures plummet to a frigid 180 degrees Celsius. Try to picture such contrast. No comforting atmosphere exists to moderate these swings, only a vacuum where the silence is absolute. Its tiny form, only 4,180 kilometers in diameter, is surprisingly dense. This density hints at a massive iron core taking up 75% of the planet's diameter. Envision a giant ball of iron, proportionally larger than any other system, spinning slowly beneath a cratered surface. This core generates a weak magnetic field, just 1/100th the strength of Earth's, enough to deflect some of the solar wind. The surface itself tells a story of billions of years of bombardment. Craters of all sizes pockmark the landscape, a testament to the relentless assault of asteroids and meteorites. The Caloris Basin, a massive impact crater over 300 kilometers wide, dominates one side of the planet. The impact was so powerful that it sent seismic waves rippling through Mercury, creating a jumbled, chaotic terrain on the opposite side. Consider that event. Mariner 10, a spacecraft from the 1970s, provided our first glimpses of Mercury's scarred face. Then, in the 2000s, the Messenger mission orbited Mercury, mapping its surface in detail, analyzing its composition, and measuring its magnetic field. Scientists discovered evidence of volatile compounds, like water ice, hidden in permanently shadowed craters near the poles, which are protected from the sun's heat. A surprise find on such a seemingly barren world. Mercury offers a glimpse into the solar system's past. Its ancient surface, largely unchanged for billions of years, preserves a record of the early days of planetary formation. Its unusual structure and orbit provide clues about gravitational interactions, the influence of stars on nearby planets, and the processes of planetary core cooling. It's a time capsule floating in space. But if Mercury is a world of extremes, Venus takes it to a whole new level. It's often called Earth's sister, but that kinship ends with size and mass. Venus is a hellish world, a cosmic pressure cooker where the heat is unbearable, the clouds are acidic, and the atmospheric pressure would crush any unprotected human in seconds. Venus is remarkably similar to Earth in size. Its diameter is about 12,000 kilometers, only 5% smaller than Earth's. Its mass is about 82% of Earth's, and its density and gravity are also comparable. If you stood on Venus, assuming you could survive, you would weigh almost as much as you do on Earth. Venus orbits the Sun of 0.72 astronomical units, or about 108 million kilometers. This is closer to the Sun than Earth, but not close enough to fully explain the planet's extreme temperatures. The real culprit is its atmosphere. The atmosphere of Venus is one of the most extreme in the solar system. It is composed of 96% carbon dioxide, with small amounts of nitrogen and traces of sulfur compounds. Thick clouds of sulfuric acid blanket the upper atmosphere, reflecting sunlight and making Venus appear bright in the night sky. These clouds reflect about 70% of the sunlight that reaches Venus, but beneath them lies a nightmare. The atmospheric pressure on Venus is 92 times greater than on Earth. This is equivalent to the pressure you would experience at a depth of 1 kilometer underwater. Any human-built base would be instantly crushed. The surface temperature of Venus, the hottest of any planet in the solar system, reaches a staggering 470 degrees Celsius. This is hotter than Mercury, even though Venus is farther from the Sun. The primary reason for these scorching temperatures is a runaway greenhouse effect. In the past, Venus may have had conditions more similar to Earth's, possibly even liquid water on its surface. However, its proximity to the Sun played a critical role in its catastrophic transformation. As solar radiation increased, temperatures rose, water evaporated, and water vapor, a potent greenhouse gas, amplified the warming effect. Simultaneously, carbon dioxide, released by volcanic activity, accumulated in the atmosphere, increasing its density and further intensifying the greenhouse effect. This dense carbon dioxide atmosphere traps nearly all of the thermal energy that reaches Venus. While the upper cloud layer reflects about 70% of sunlight, the 30% that penetrates is absorbed by the surface and cannot escape back into space due to the thick layer of carbon dioxide. This process turns Venus into a thermal trap. The temperature on Venus is remarkably uniform across the surface, with minimal variations between day and night or between the equator and the poles. This is due to the high density of the atmosphere, which distributes heat evenly around the planet. Even at night, when the sun does not illuminate the surface, the temperature remains almost as high as during the day. Beneath the dense atmosphere of Venus lies a mysterious world. What happened next changed everything. The silver curtain pressed closer. A metallic tang filled Maya's nostrils, sharp and unfamiliar. Below the curtain, chaos reigned. Cars crashed into each other, their horns blaring a discordant symphony of panic. People screamed, pointed, and ran in every direction, their faces etched with terror. The air crackled with an unnatural energy, making the hairs on Maya's arms stand on end. This was no ordinary day. Radar penetrates Venus's thick clouds, revealing a world of volcanoes. Its surface is almost entirely covered with lava plains formed by eruptions long ago. Maxwell Montes, one of the highest points, rises to approximately 11 kilometers, dwarfing Mount Everest. Vast plains dominate much of Venus, punctuated by strange geological features like coronae, enormous circular structures created by magmatic activity. These coronae signify powerful tectonic processes that occurred billions of years ago. Intriguingly, despite the presence of volcanoes and lava flows, Venus lacks clear evidence of plate tectonics like Earth. Instead, its crust bends and fractures under pressure from magma, producing unique landforms. Powerful winds, reaching speeds of up to 360 kilometers per hour, whip around the planet at an altitude of roughly 60 kilometers. This phenomenon, known as superrotation, sees the atmosphere circling Venus far faster than its surface rotates. Venus completes one rotation on its axis in 243 Earth days, the slowest of any planet. However, a year on Venus lasts only 225 Earth days, making a Venusian day longer than its year. Venus was among the first planets explored by spacecraft. Soviet Venera missions were the first to send probes to its surface. Venera 7 transmitted data, but survived for only around 30 minutes in the extreme heat and pressure. The European Space Agency's Venus Express mission studied the planet's atmosphere and dynamics, including the super-rotating winds and chemical composition of clouds. Future missions such as Veritas and Envision will study Venus's topography and internal framework. These will help unravel whether Venus could have been habitable in the past. Earth, our home, is next. What makes it unique? Why does it remain the only known haven for life? Liquid water distinguishes Earth. Oceans, seas and rivers cover approximately 70% of its surface. Water is fundamental for life. Its unique properties, like high heat capacity and solvent capabilities, make it ideal for supporting biological processes. Why does Earth have liquid water, while Venus and Mars do not? The answer lies in its location. Earth resides within the habitable zone, the region around a star where temperatures allow liquid water to exist. Closer to the Sun, Earth might have mirrored Venus's fate. Farther away, it could have become a frozen desert like Mars. Equally crucial is the magnetosphere, a magnetic field protecting our planet from solar wind and cosmic radiation. Generated by the movement of liquid iron within Earth's core, it acts as an invisible shield. Without it, the solar wind could have stripped away our atmosphere, as happened to Mars. Consider solar wind. This is a stream of charged particles continuously emitted by the Sun. Originating from its hot outer layer, the corona, these particles travel at speeds up to 800 kilometers per second, spreading throughout the solar system. Solar wind interacts with planets, causing various phenomena. It creates auroras on Earth and interacts with the magnetosphere, which protects us from its destructive force. Earth is dynamic. Plate tectonics constantly reshape its surface. The Earth's crust is divided into several large and small tectonic plates that float on the semi-molten mantle. These plates move, collide, diverge, and slide beneath each other, creating mountains, ocean trenches, and earthquakes. Plate tectonics plays a vital role in the planet's cycle of materials. Carbon dioxide released by volcanoes helps maintain the greenhouse effect, which is essential for retaining heat. Plate movement also renews the Earth's crust, promoting long-term planetary stability. Volcanism represents another crucial aspect of geological processes. Volcanoes, beyond their destructive power, supply new materials to Earth's surface. They release gases such as carbon dioxide and water vapor, which influence climate and minerals that enrich the soil. Earth's atmosphere is yet another unique feature. Its composition is perfectly balanced to support life. Nitrogen makes up approximately 78%, oxygen around 21%, along with smaller amounts of carbon dioxide, argon, and other gases. This balance is not accidental. It has evolved over billions of years through biological and geological processes. Oxygen appeared in the atmosphere thanks to ancient microbes that began producing it through photosynthesis. This event, known as the Great Oxidation Event, occurred around 2.5 billion years ago and changed the planet's chemical composition, rendering it suitable for complex life. Carbon dioxide, though a minor component, plays a key role. It regulates the planet's temperature through the greenhouse effect, preventing Earth from freezing. This delicate balance makes our planet comfortable for life, but it is also vulnerable. Any significant changes in carbon dioxide concentration can lead to climate catastrophes, as happened on Venus. Discussing Earth necessitates mentioning its constant companion, the Moon. More than a beautiful object in the night sky, the Moon is essential for Earth's stability and the development of life. The Moon's diameter is around 3,470 kilometers, making it the largest satellite in proportion to its planet. Firstly, the Moon stabilizes Earth's axial tilt. This ensures that the tilt remains relatively constant, providing stable seasons and climate. Without the Moon, Earth's axis could wobble much more severely, causing chaotic climate changes. Secondly, the Moon causes tides. The gravitational pull of the Moon creates bulges of water on the sides of Earth closest to and farthest from it. As Earth rotates, different locations pass through these bulges, resulting in high and low tides. These tides play coastal ecosystems and have likely influenced the evolution of marine life. The presence of the Moon has shaped our planet in profound ways. Back in Maya's world, the silver curtain continued its descent. The metallic tang grew stronger, almost overwhelming. People huddled together, seeking comfort in shared terror. Some prayed, others wept. Maya clutched her notebook. The doodled constellations now a cruel reminder of what had been lost. The air thrummed with an oppressive energy. The ground vibrated beneath her feet. The silver curtain touched down, silencing the screams, extinguishing the lights. What? The silver curtain pressed down. the metallic scent intensifying, coating Maya's tongue with a bitter, coppery taste. The oppressive energy made the hairs on her. It felt like standing beneath a colossal, silent machine. This was no ordinary weather phenomenon. It was something alien, something wrong. The silence after the curtain touched down was absolute. The screams, the sirens, the weeping all ceased as if a switch had been flipped. Maya squeezed her eyes shut, bracing for something. She didn't know what to expect, but the nothingness was somehow worse. When she finally dared to open them, the world had changed again. The silver curtain was gone, but so was everything else she knew. The familiar streets of her town were replaced by a desolate red landscape. Towering rock formations pierced the horizon. A thin, pinkish sky stretched above, offering no warmth, no comfort. The air was frigid, biting at her exposed skin. She was alone. Utterly, terrifyingly alone. The metallic tang lingered, a phantom taste of the impossible. Maya stumbled forward, her sneakers crunching on the rusty-coloured dust. Each step was an effort, the gravity subtly different, heavier than she remembered. Her breath hitched in her throat, each inhale a struggle in the thin atmosphere. Fear, cold and sharp, clawed at her insides. Where was she? What had happened? This new world was a stark contrast to the Earth she knew. The moon, with its stabilizing influence on Earth's axial tilt, seemed a distant memory. Without the moon, Maya knew the Earth's climate could become chaotic. She remembered her physics teacher droning on about the tides sculpted by lunar gravity. Tides that shaped coastal ecosystems influenced the very. Now, there were no oceans, no tides, only the desolate whisper of wind across the red plains. She noticed something glinting in the distance. Hope, fragile as a butterfly's wing, fluttered in her chest. Maybe, just maybe, she wasn't completely alone. She started walking towards it, her legs burning, her lungs aching. The glint resolved into a metallic structure, half buried in the red dust. It was angular, alien, and undeniably artificial. As she drew closer, she recognized fragments of familiar technology integrated into the structure. Scraps of solar panels, twisted metal that might have been part of a vehicle, and sections of insulated wires. It was a crash site, a human crash site, on this alien world. The structure was a mangled mess, a testament to a violent impact. Maya circled it cautiously, her heart pounding. There were no signs of life, only the cold, silent wreckage. She noticed a symbol etched into a piece of debris, a stylized circle with 3 lines radiating outwards. It was a symbol she vaguely recognized, something from a history book, a symbol of early Martian colonization efforts. The realization hit her like a physical blow. She wasn't just on another planet, she was on Mars. But Mars looked nothing like the images she had seen. This was a Mars ravaged, desolate, and seemingly devoid of life. A far cry from the dream of a new home for humanity. How had she gotten here? The silver curtain, the metallic taste, the sudden shift. It all pointed to something far beyond her understanding. Some kind of instantaneous transportation, a tear in space-time, a nightmare made real. The crash site implied that others had come before her, others who had failed. She searched the wreckage frantically, desperate for any sign of survivors, any clue to what had happened. She found a tattered logbook, its pages brittle and faded. The entries were cryptic, filled with scientific jargon and fragmented observations. One passage stood out, scrawled in frantic handwriting. The anomaly. It's changing us. The silver. It's alive. Alive. The silver curtain. The impossible idea sent a shiver down her spine. What did it mean? Was it a sentient being, a technological weapon, a cosmic force beyond human comprehension? The logbook offered no answers, only more questions. Maya clutched the logbook to her chest, the fragile pages her only connection to a lost world. She was stranded on a desolate planet, surrounded by the wreckage of a failed mission, haunted by the mystery of the Silver Curtain. The odds were stacked against her. Survival seemed impossible, yet a spark of defiance flickered within her. She would not give up. She would find a way to survive. She would unravel the mystery of this alien world. The sun, a pale disk in the pinkish sky, began to sink towards the horizon, casting long, eerie shadows. The temperature plummeted, the air growing even colder. Maya knew she needed shelter, and fast. The alien structure offered little protection, but it was better than nothing. She crawled inside the wreckage, huddling against a twisted metal panel. The wind howled outside, a mournful sound that echoed across the desolate landscape. Fear gripped her, but she pushed it aside and forced herself to focus. She needed to think, to make a plan, to survive. Her hands shook as she searched through her backpack. Inside, a half-eaten granola bar, a water bottle, a notebook, and a pen. Her only tools, her only hope. It wasn't much, but it was a start. She opened the notebook. The familiar pages offered a small comfort in this strange place. She began to write, the pen scratching softly against the paper. She described the red landscape, the wreckage, the flight log. She poured onto the page her fear, her hope, her resolve. Writing kept her grounded, helped her hold on to who she was. And as she wrote, she noticed something odd. The doodles she had made in physics class, the constellations she had absent-mindedly sketched in her notebook, seemed to glow faintly in the dim light. The stars, once a distant memory, now seemed to pulse with a faint inner light. She traced her finger across the constellations, a strange feeling washing over her. It was a sense of connection, of understanding, of power. The constellations seemed to resonate with something within her, something she couldn't explain. The wind howled louder, the shadows deepened, and the red landscape seemed to press in around her. Maya looked up at the faint glowing constellations in her notebook, a glimmer of hope flickering in her eyes. She didn't know what was happening, but she knew one thing. The stars were not just doodles anymore. They were something more, something important, something that might just help her survive, but beginning. Jupiter, the solar system's self-appointed cosmic shield, sweeps up asteroids and comets that would otherwise threaten Earth. A world of perpetual storms, crushing pressure, and a magnetic field stretching millions of miles. The great red spot, that eternal blemish, endures alongside incredible auroras and 4 massive moons, each a planetary system unto themselves. Over 318 times Earth's mass. Adding more wouldn't increase its size. Gravity would simply compress it into an even denser sphere. Surface gravity is too stronger than Earth's, so a person, impossibly standing on Jupiter, would weigh 2 their normal weight. But surface is non-existent. Jupiter mirrors the Sun, primarily composed of hydrogen and helium. Descending through the outer clouds initiates a journey through layers of ever denser gases. An atmosphere swirling with ammonia and methane hosts hurricanes spanning thousands of kilometers. Pressure intensifies, transforming hydrogen into a liquid, then a metallic state, a substance achievable on Earth only under immense pressure. A metallic hydrogen ocean, tens of thousands of kilometers deep, conducts electricity. This generates Jupiter's colossal magnetic field, reaching millions of kilometers. A small rocky core, perhaps Earth-sized, may exist deeper within, though its fate under such pressure is debated. Jupiter remains Jupiter because of its churning atmosphere, adorned with distinctive bands. Light and dark zones signify powerful winds moving in opposite directions at speeds up to 600 kilometers per hour. The entire atmosphere is a boiling ocean of gas, swirling into bizarre patterns. Lightning flashes thousands of times brighter than on Earth, while pressure transforms gas into a liquid state in lower layers. Then there's the Great Red Spot, a veteran storm raging for at least 350 years. Its diameter, currently around 16,000 kilometers, dwarfs Earth, though it's slowly shrinking. Whether it will vanish remains unknown, but its presence is one of the most awe-inspiring phenomena. Jupiter's magnetic field, the solar system's strongest, dwarfs Earth's by 20,000 times. It creates a magnetosphere so vast that, if visible, it would appear larger than the moon in our sky. Jupiter is also a powerful radio emitter. Streams of charged particles surround it, and radiation is lethal even to shielded spacecraft. Juno mission uses intricate maneuvers to avoid the most dangerous zones. Beyond the gas giant itself, Jupiter boasts a system of over 80 moons, most notably the 4 Galilean moons, Io, Europa, Ganymede, and Callisto. Each is a distinct world with unique history and characteristics. Io is a volcanic inferno, the most geologically active body. Volcanoes constantly erupt lava kilometers high, coating its surface in sulfur, giving it a vibrant yellow hue. Tidal forces from Jupiter and other moons heat its interior. Europa, an icy world, is covered in a kilometers-thick ice crust, concealing a liquid water ocean, larger than all Earth's oceans combined. Cracks across the surface caused by Jupiter's tidal forces feature geysers spewing water into space. If life exists elsewhere, Europa is a prime candidate. Equally fascinating is Ganymede, the largest moon. Larger than Mercury, it's the only moon with its own magnetic field. Its surface, scarred by ice and ancient craters, may hide a subsurface ocean. Callisto, an ancient, heavily cratered world, is among the oldest objects its surface of years. Like Ganymede, it may also harbour a hidden ocean beneath its icy shell. Jupiter was first explored up close in the 1970s by the Pioneer and Voyager probes, with more detailed studies by Galileo in the 1990s and the current Juno mission. Future Jupiter exploration promises even more excitement. The JUICE mission will head to Ganymede in the 2030s, and the Europa Clipper will study Europa's icy surface, searching for evidence of potential life in its ocean. Jupiter is undoubtedly the king of planets. Saturn, Jupiter's neighbour, is no less astonishing. A world of unparalleled beauty, encircled by the solar system's grandest ring system, it possesses Titan, a moon where it rains liquid methane. Moving onward reveals the secrets hidden within this enigmatic planet. Our journey continues past Jupiter, towards Saturn, a planet of unparalleled beauty. If Jupiter reigns supreme in size and power, Saturn is its aristocratic counterpart, adorned with the most spectacular ring system, making it unique. Saturn, the second largest planet, has a diameter of 120,536 kilometers, approximately 9.5 times Earth's. Despite its immense size, Saturn is the lightest planet. Its average density is less than water, meaning it would float in a sufficiently large ocean. Its rings, composed of ice and rock particles, are a constant source of fascination, their origin a topic of ongoing research. Saturn's atmosphere, similar to Jupiter's, consists mainly of hydrogen and helium, with traces of other elements. Wind speeds can reach up to 1,800 kilometers per hour, some of the fastest. Storms rage across its surface, though less prominently than on Jupiter. One notable feature is the North Polar Hexagon, a persistent six-sided cloud pattern. Saturn boasts a vast system of moons, over 80 confirmed. Titan, its largest, is unique. It has a dense atmosphere, composed primarily of nitrogen, and experiences rain, rivers, and lakes of liquid methane and ethane. This makes it the only celestial body besides Earth, known to have stable bodies of liquid on its surface. Enceladus, another moon, is known for its cryovolcanoes, which eject plumes of water vapor and ice particles into space, contributing to Saturn's E-ring. Numerous missions have explored Saturn, including Pioneer 11, Voyager 1 and 2, and Cassini-Huygens. Cassini in particular provided invaluable data about Saturn, its rings and its moons, before its deliberate plunge into Saturn's atmosphere in 2017. Future missions may explore Saturn's moons further, particularly Titan and Enceladus, in the search for extraterrestrial life. This gas giant world holds many secrets still waiting to be discovered. Maya shivered, pulling her threadbare jacket tighter. The information flooding her mind, facts about gas giants and icy moons, felt utterly useless against the backdrop of the silver sky and the red dust swirling around her. Still, a strange comfort bloomed with each recalled detail, a fragile anchor to the world she knew, the world that was now irrevocably gone. The pulsed again, brighter this time. A faint hum resonated within her, growing stronger with each passing moment. She closed her eyes, and a rush of images flooded her mind, swirling clouds of ammonia, icy geysers erupting into space, methane rain falling on a distant moon. It was overwhelming, terrifying, and exhilarating, but beginning. Maya gasped, the visions receding. Saturn, Titan, Enceladus. These weren't just facts anymore, they were destinations. A strange pull tugged at her, a sense of urgency she couldn't explain. The red dust swirled faster, coalescing into miniature tornadoes that danced around her feet. Her notebook vibrated in her hand, the constellations glowing with an almost painful intensity. She felt a prickling sensation all over her skin, as if millions of tiny needles were simultaneously piercing and healing her. Saturn, a giant among giants. Its diameter dwarfed Earth's, a humbling comparison. Yet, for its size, it's the lightweight champion of the solar system. Imagine a cosmic bathtub big enough to hold Saturn. It would float. It's than water. The most striking feature remains its majestic rings, making it instantly recognizable. Photographs often depict these rings as solid disks, a deceptive illusion. Instead, they are composed of billions of each orbiting the planet. These particles vary greatly in size, from minuscule dust motes to chunks as big as houses. The rings are incredibly thin compared to their vast width, averaging only about 10 meters thick. Imagine a colossal flat disk, so slender it nearly vanishes when viewed edge-on, stretching over 200,000 kilometers across. The origin of these spectacular rings remains a topic of debate among scientists. One prevailing theory suggests they are the remnants of a shattered moon, torn apart by Saturn's immense gravitational forces after venturing too close. Another hypothesis proposes they are material that simply failed to coalesce into a moon due to the planet's gravitational influence. Within the rings, fascinating formations exist, such as the Cassini division. This significant gap, spanning approximately 4,800 kilometers, neatly divides the rings into two distinct sections. The culprit behind this division is Saturn's moon Mimas. Its gravitational pull sweeps away particles from this region, creating the noticeable gap. Like Jupiter, Saturn's atmosphere primarily comprises traces of other gases that lend the clouds a yellowish hue. Jupiter boasts its Great Red Spot, but Saturn has its own enigmatic structure, a hexagonal storm at its north pole. This isn't just any storm, it's a scientific anomaly. Picture a gigantic hurricane 25,000 kilometers wide, shaped like a perfect hexagon. Inside, winds rage at speeds exceeding 500 kilometers per hour. The storm's edges remain remarkably defined, as if drawn with a ruler. Scientists are still puzzled about the reasons behind this unique shape. This isn't the only atmospheric phenomenon on Saturn. In 2010, its northern hemisphere unexpectedly shifted in color, from bluish to golden. This transformation resulted from photochemical reactions triggered by sunlight. As summer arrived in that region, ultraviolet radiation broke down molecules that gave the atmosphere its blue tint, causing the clouds to take on a warmer hue. But Saturn, a planet, it's a host to 83 moons. Among these, Titan stands out. It's one of the most intriguing objects. Titan, the second largest moon after Ganymede, is larger than Mercury and a dense atmosphere. This atmosphere makes it truly special. Standing on Titan's surface, the sky wouldn't be blue, it would be orange-yellow. Frozen hydrocarbon plains would stretch out before you. Strangest of all, it rains on Titan, not water, but temperatures plummet to minus 180 degrees Celsius, so water exists as hard as rock. Rivers, lakes, and seas are composed of hydrocarbons, which remain liquid at these frigid temperatures. This world eerily resembles Earth. It experiences seasons, clouds, and precipitation. Its rivers and lakes fluctuate with the changing seasons. Methane seas gradually evaporate in some areas, while new bodies of liquid appear elsewhere. Deep beneath Titan's surface, a liquid water ocean might exist. If so, it could harbour conditions suitable for life. While Titan captivates with its dense atmosphere, another of Saturn's moons, Enceladus, stuns with its geysers. This small world, only 500 kilometers in diameter, has proven to be surprisingly active. The Cassini spacecraft discovered that jets of water erupt from Enceladus's south pole, forming entire clouds in space. These geysers are so powerful that their particles contribute to one of Saturn's rings. Beneath Enceladus's surface lies an ocean of liquid water. Organic molecules and traces of chemical reactions, potentially providing energy for life, have been detected within it. This places Enceladus, alongside Europa, as a prime candidate extraterrestrial life within our solar system. The Cassini-Huygens mission conducted the most detailed studies of Saturn and its moons. Launched in the 1990s, this probe spent 13 years in the Saturnian system, transmitting thousands of images and unique scientific data. The Huygens probe, separating from Cassini, landed on Titan, becoming the first spacecraft to touch down on the surface of a moon orbiting another planet. It sent back images of orange haze, rocky plains, and evidence of ancient riverbeds. In 2017, Cassini concluded its mission by plunging into Saturn's atmosphere, transmitting data until its final moments. The silver curtain above shimmered again, pulling Maya's attention back to her immediate surroundings. The red dust seemed to pulse in sync with her heartbeat. They were now blazing, almost blinding. The knowledge of Saturn, Titan, and Enceladus felt less like comforting facts and more like a roadmap to somewhere. The hum within her intensified, resonating with the strange energy emanating from the sky. She looked at her hands, noticing faint silvery lines tracing patterns under her skin. The lines mirrored, doodled, the constellations that now dominated the sky. She felt a change occurring not just within her mind, but within her very being. It was both terrifying and inevitable. What? The silver curtain rippled, a silent echo of some cosmic event. Maya's breath hitched. Red dust swirled around her, a gritty dance against the alien sky. The constellations blazed, searing her vision. She remembered Uranus, a world of methane clouds and diamond rain. A giant tilted on its side, forever bathed in an odd perpetual twilight. Voyager 2 flew past in 86, a fleeting glimpse. No return visit planned. The knowledge felt different now, raw,